In this question, we're tasked with finding the last digit of 2 to the power 2 to the 2024. Now, this number is astronomically large, and working this out directly would be unwise. Now, instead, I'm going to look at the first few powers of 2. 2 to the 1 is equal to 2. 2 squared is equal to 4. 2 cubed is equal to 8. 2 to the 4 is equal to 16. 2 to the 5 is equal to 32. 2 to the 6 is equal to 64. 2 to the 7 is equal to 128. And 2 to the 8 is 256. Now, just looking at these first 8 powers of 2, we can observe a pattern. And it looks like, if we focus on the last digits, we have 2, 4, 8, 6, and actually this repeats in the second row. 2, 4, 8, 6. So it seems from these examples we may have a cycle of length 4. And the last digits of consecutive powers of 2 are 2, 4, 8, 6. Now, we mustn't assume that this pattern continues. If we think it might continue, we need to provide some reasoning for that. Let's consider the calculation 123 multiplied by 456. Now, I'm not going to carry out this full calculation, but what I would like you to think about is, what would the last digit of this result be? And what is it that actually affects the value of the last digit? After some thought, you'll probably see that we only really need to calculate 3 times 6. And essentially what we're saying is, to get the last digit of this product, we only really care about the last digits of each number in the product. Now, 3 times 6 is 18. And this tells me that the last digit in the product, 123 times 456, is 8. Now, we can use this idea in our original problem because we conjectured, so we spotted a pattern that we believed might continue, and we conjectured that our powers of 2, the final digits, would cycle. And now we can actually give some reasoning to that, and we can justify that, in fact, they do cycle, and this behaviour will continue. OK, so our conjecture was that the last digits of the powers of 2 will cycle, and the cycle was 2, 4, 8, 6. And we are in a position now where we can justify that this does continue. If you consider a power of 2 where the last digit is a 6, when we multiply by a further 2, we're going to get 2 times 6, which is 12, which ends in a digit 2. So in fact, when we multiply a power of 2 that ends with a 6, we will end up with a power of 2 that ends with a 2. And this cycle will continue. OK, so back to the problem at hand. We would like to know the last digit of 2 to the power 2 to the 2024. So I'm going to focus, first of all, on this exponent here, or power. So 2 to the 2024 is certainly a multiple of 4, because its prime factorisation is 2024 2's all multiplied together. So because this is a multiple of 4, what we're looking at here is a power of 2 where the power is a multiple of 4. And if we think about where that would fit in our cycle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Every fourth power of 2 will end with a digit 6. And that tells us that this astronomically large number ends with the digit 6. And that is our final answer.